Okay, we'll begin the class now. So today will be the last experiment that we are going to discuss in this control system lab class. What is the title of the experiment? I'm hoping all are having the manual copy with you.
State space model for classical transfer function and design and turning PID controller.
Because I kept the speaker in a very low volume, I'm not able to hear what you're speaking.
PID controller.
Okay, so this experiment has two parts, alright. One, how to convert given system's transfer function to a state space model. Then how to do it in the reverse action. That is, they would have given you what are the ABCD constants with the help of which you will be required to convert it into a system. Okay, so there are three codes actually in the experiment. The first code is how to do the transfer function to state space model conversion. Then the reverse thing, how to convert state space representation to transfer function. The third thing is how to tune and then obtain the step response and observe how the step response is improving. Okay, so these three are the things that you are going to discuss in this class. All are able to see the screen that I'm representing?
Yes, ma'am.
Okay, so we'll discuss first thing first. So this is the first code. Okay, this is the first code. So tell me what has been given as part of this code. By this time you would have understood what is the context of giving numerator, denominator, then this is your system. So what does these three syntax mean? What do they do? This is what order system actually? These two, these three. Command response should be from your side. This is the last lab class. Please be active. What is the transfer function as per this three number of syntax that is given? Order is, I think, 2s to the
4.
power 5 plus 1s to the power 4 plus 1s to the power 3 plus I think it's fourth order. Fourth order only, no.
And fourth order.
Fourth order system, I think so. So 2s to the power 4 plus s cube plus 1s square plus 2s. The constant is 0. Okay, so this is your denominator polynomial. The constants are 2, 1, 1, 2, 0. Okay, and in the numerator you are having this is your constant, then 3s plus 2s squared, I think so. So this is your given system transfer function. Okay, that is given by the first three statements. So given systems transfer function, you are going to convert it into a state space model. Okay, so what is the syntax for obtaining the state space model? You know, in morning class I told you that it is equivalent to x dot into ax plus bu and y is equal to cx plus du. So I want to know what is a, b, c, d. Okay, so in order to obtain those, I am having the syntax. This is representing transfer function to state space conversion of the given system. So this is a very easy code to remember. So this via this coding you are doing what conversion? What conversion?
From transfer function to state space model.
Yes, they would have given you one transfer function and you are going to convert that into a state space model. Now we want to reverse the thing. Okay. Now you know ABCD constants. Okay, ABCD constants. Okay. This is your ABCD matrix. In terms of array, they have represented as matrix representation. Okay, so A is 0, 1, 0, 0, 0, 1 minus D minus 3, 4, 3 cross 3 matrix. Okay, and B is 0, 0, 1, C is 1, 0, 0, D is 0. So they have given state space model and you need to convert that into a transfer function. So the numerator and denominator of the transfer function is given by this command. Okay. So here this command represents what conversion? Given detail is state space, that is to be converted to what equivalent form?
Transfer function.
Transfer function. So SS to state space to transfer function they have given, and finally the transfer function. Okay, so this is second part of the code program. So finally, there is a third code, and whatever results you are obtaining in the command window, that you have to cut and copy here, paste and here. Okay. For the first thing, you need to write down what is the transfer function that would have been displayed in the command window, and what are A, B, C, D constants. You just copy and paste in the empty spaces. That's all. For that purpose only, they have left the space. Next thing is, I have taught you in class Zeiger-Nichols tuning. Okay. This is first method or second method? This is the existing plant to which you are going to add up a PID controller in series. So you need to know the three constants, Kp, Ti, Td. You need to tune by what method?
Zeiger-Nichols.
Zeiger-Nichols tuning, first method or second method? They themselves
First
have given.
method.
First method.
So first method is possible when there is no zero at the origin, no pole at the origin, and no complex roots should be present very close to the origin imaginary axis. In that case, you can apply first method. So how will you be proceeding with the first method? This is the tabular column with the help of which you are going to decide the three parameters Kp, Ti, Td. But the problem is you don't know the value of T and L. Okay, so what are T and L? From this club on graph, I have already shown you know the step response output. You will be giving the system a step input, and you will observe the nature of the response. It should be an S-shaped curve. In that S-shaped curve, you will note down the 2 points. Okay, L and T. What does L and T represent? T is your time constant. L is your delay time. Okay, so how will you identify these two parameters? Told you the procedure and all in class. No, you have to draw what? This class will test my patience if I am to get one silly answer from your side. What do you need to draw in order to obtain the L and T parameter?
Ma'am, tangent.
Yes, you have to draw the tangent line. Okay. Then wherever it intersects here, with that you will be finding out T and L. Okay, and then you will substitute the T and L in this formula to find out Kp, Kti, Td. And programming part we'll discuss now. So given input is what now? Is what are the things that are given here first?
Matrices value.
Yes, A, B, C, D constants are given. That is state space model is given a transfer function. That is my question.
State space.
State space. So you need to first convert that into what?
Transfer function.
Transfer function. Okay, that is the first part of the program. Then for that system, you are going to apply what input? If you keep silence, I will also keep silence. Then everything will go very good.
Ma'am, step input.
So you are going to give step input, then you are going to obtain the response from the figure. From then you are going to obtain the closed loop system's response, step of the closed loop. So this curve you will be getting this curve, okay? That is the step response of the closed loop system. Open loop system we are going to discuss. And then from that curve you will zoom it, and by axis property addition you are going to add a tangent like this. Then you have to find out L and T. Then using L and T you have to determine the parameters Kp, Ti, Td by using the tabular column. This tabular column. Then you are going to substitute that in the given program. There is an empty parameter here listed. They have not listed out what is Kp, Ti, Td. In that you have to substitute these parameters. And again you have to obtain the transfer function in S. Then you are including the controller. Then you are obtaining again the step response after the inclusion of PID controller, and you will be checking out how the system performance is improving after the addition of PID controller. By I think 3 sets of tuning you have to do, I think so. So how the settling time improves you are going to tabulate, that's all. Okay, so I'll present from the next system how this is to be done. So I'll quit presenting from here. I opened my MATLAB already, so in which I am typing the program. Try to understand the program. Here, for convenience of time, I am cutting and copying. The same you cannot do in model practical. I am opening a new editor. Pasting the program. Okay, it's already copied. Test. I will save the program and I will run. This is where I will be doing what conversion. See, it's not me that is going to obtain credits by answering my question. Okay, it's you who is to learn, not me. If you are being silent, it irritates me to a higher degree. I always tell, even if it is wrong, you should respond from your side. If you are keeping silent, it irritates me and tests my patience. I'm telling you. You behave like this. Whenever you pose a question to me, I will also remain silent. The thing goes side both ways.
State space transfer function.
So you can see for yourself with the command meter what is being displayed here.
1007.
Transfer function.
So this is my program where I am doing what conversion now, transfer function to state space conversion. So the answers for the constants A, B, C, D are displayed here, that you have to cut and copy and you can paste it in the lab manual copy. That's all. Here also I will remove, okay, the semicolon so that I will be able to understand what is the transfer function representation that is being given in the code. Again, I will run. So again, you see for yourself in the command window, I am having the transfer function also displayed. The same one that I have taught you here while I was presenting. So this you cut, copy, okay, and you paste it in your document, first part. So system transfer function, you have to cut, copy, not the program. So this is my system transfer function that I will copy, Control C, and I will paste it in my transfer function. This is my system. Then comes the state space model. What are ABCD constants that I have pasted now? So this is my AB constant. I will copy it again up to C, E. Again, I have to paste it here. Now copied it.
Ma'am, that command
I just
TF,
copy. What?
that command TF2SS, that command we are using to convert transfer function to state space.
EF to SS, you have to convert it into what? You are telling
Ma'am,
me?
the ABCD, that last line of code, TF2SS, bracket numerator,
Yes.
comma denominator, that
Okay, what
code is
about that?
simply changing the transfer function to state space.
Yes. You are
And
having any
before
doubt regarding that?
before that there is another TF, numerator, comma denominator, that is doing what? That is converting into transfer function.
This is numerator and denominator. Still, you have not got the system transfer function. These are just representation of polynomials. So first you are deriving the system. So system is actually indicated by its mathematical model, that is transfer function. You using this command, you are getting the transfer function. Then after getting the transfer function of the system only, you are converting it into ABCD constants. State space model.
Okay.
Understood, Swaraj?
Yes, ma'am. Yes, ma'am.
Okay, next part of the program where you are going to do what?
Ma'am, find the tangent.
Not tangent, the other way around. You are now going to convert state space model into equivalent transfer function. So this is the command. Copying the program. You want means you can change the transfer function. Whichever transfer function you want to use, you use. It's not mandatory that you are required to use the same one. Okay, so the second option where these are the ABCD constants. State space model is given. Using the state space model, I want to convert it into transfer function system. Okay, so again I'm saving it. Running. Okay, so the system transfer function is 1 divided by S cube. I will copy it and I will paste it in the place where it is to be set. So here I will copy it. Paste. This is my system. State space model. I will copy again. First two should be done like this. So this is how you are converting transfer function to state space model and state space model to transfer function. And final part, the PID tuning program is this one. Copying again. Program. And I will save it and run. error in 17.6. Okay, that the space is empty. Okay, because of which it is telling that there is an error. Okay, first let us see. We'll put on percentage. Because we are not knowing the values yet. So we'll do by step. We have to design all these things. I'm not going to use the last portion of the program. 7.9. So you can see for yourselves the state space model is converted into the transfer function. Then one graph will pop up, one for closed loop and one for open loop, I think. Wait for some time. So from the closed loop response, you have to obtain L and T by drawing a tangent. The figures are popping up. First figure, both figures are there. Okay. So from the open loop system or closed loop system, I will find out PID controller. You can change the register number and name.
Ma'am, from the code only we can change. In the code it is given.
That you can do. That is a silly thing that you can do. You already know what to change. I'm not going to teach you that thing again. So red color shows your closed loop. Blue color shows without closed loop. One of the graphs you have to draw a tangent. Okay, which one I will check for it. I think the systems only you have to check. Red color one only. Sorry, the blue color one I think. For the original system without feedback, you zoom it and then you insert tangent, okay, by using edit axis properties. Or you have to do it manually. Either way. There is a line, no, that you have to draw. Okay. Okay, using a line, you make a tangent, like I'm doing. or you do it manually if it's very difficult. Before that, you have to zoom the graph, so you know how to edit. Access properties. So I will zoom it to 5. Okay. Like this, zoom it, and then you fix up the tangent. Okay, to the blue color line only, you have to draw the tangent, I think. So draw the tangent. Like this, you draw the tangent, and you know from the model graph how to check out what is L and T. Okay, so this up to this is my L or T. Which one?
Ma'am, from origin to that point,
Origin to
origin
L or
to
T,
the
this
time
one.
L.
This one is L. Okay, so around 0.7 or something it's coming. Okay, till I can zoom it and I can check out what is the point. And here up to this, from that to this line, it's my T. Okay, I think so. So you can calculate L and T this way, then you substitute in the tabular column. Okay, this tabular column. Like this, you find out L and T. When you fix that L and T value in the tabular column, this tabular column, somebody calculate KP, TI, TD and tell me. T is what and L is what? Are you doing the program?
Ma'am, can you show your PID tuning program in MATLAB?
Program,
Yes.
this one. What doubt you are having there?
What value did you give for KP, KI?
KP, KI, KD we are designing. That means you did not understand whatever things I was telling you. Using L and T only you can design KP, TI, TD. Now only you are doing that. That only I am asking you to calculate that.
Ma'am, can you scroll it down a little bit, the code?
I am not giving KP, KI, TD. That I have kept it. You need to tell me the value. After that only I will substitute and I will tune it and I will observe how much the settling time is better.
Yes.
Somebody who should tell me L and T. You calculate from the graph and tell me. I am taking L to
TD,
define.
ma'am, we will plot graph and tell.
Huh?
Ma'am, you tell us the value of KP, TI, TD, ma'am. Then we will plot the graph and we will tell the value.
Why you are students? Why should I tell you the value? I have told you the procedure. From your side, you should calculate L and T. Everything. If I spoon feed you, then what is the necessity of you being a student in my class? No need. I have already crossed the control system. I have passed my subject. Okay. You are the people who are to be tested, not me. Okay, since you people are not going to tell, I'm inserting another line. So this is my L point. So the final value also, steady state value also I have to check it out to calculate T. So again I'm editing the property. 7 of 10. So this is my steady state value that is shown in dotted line. So now the tangent is moved up. Zero. Up to this, you calculate L. You are to tell me the answer. I am not going to tell. I think around 0.7 or 0.75 you get. Then this is my steady state value. From there, I have to draw a straight line, and that will be my P. My P from here to here. Calculate L and T. We use edit properties to calculate value also, I think. There is some cursor or something from which you can obtain what is the point in x-axis and data cursor. You can use it. So as a result, nobody is going to tell me what is L and T. Some cursor is there, you can use that to check out what is the value. Time is around 0.63, I think so. L. Okay, it's showing now. All are able to see,
Yes, ma'am.
I think 0.639. Similarly, this point.
751.
No, it's 2 point something. No? I think it's 2.63. So 2.63 minus what was the earlier value? This is 2.63 minus this you have to make 2.63 minus 0.63. Around 2 you will get as T. L is 0.639. So calculate KPTA and TD and tell me from this table. This table. I think KP is 3.76 something. You see what we people are, how we people are faring in the model lab. See, do one silly mistake. I will set up easy question paper only. If you are doing one silly mistake, see how much marks I will give. So values of KP, TI and TD I have given now. Now I will cancel out the percentage and I will run the program again. So far I have corrected all your lab records liberally only. See, for the last experiment, do one copying or simple mistake and you will get low grade. Let me see from my side. One simple answer also people cannot give. And people talk very great, like the people are very good. Okay. So the final PID transfer function also is given. Let me check what is the settling time. So this is a graph that I am getting. So this is with the PID controller. It's not good. I'll close the graph and run again. It's better. So with the controller, there is no improvement.
Yes.
That is only for PID controller again. One important thing note to do. Okay, this is how it is to be done. But I am not seeing any considerable improvement. So let's use a different transfer function or different things. Let me check up control system Nagarkani book. Okay, let me select one controller. I'm skipping this ABCD concept. Directly, I will try to give the system. Yes, I'm trying to figure out. All are doing this three sets of program or simply you are sitting staring at the screen.
Ma'am,
Doing,
doing,
ma'am.
ma'am.
Doing, ma'am.
Check whether the L and T constants that I have found out is correct or not. 0.63 and 2. Maybe
Yes,
I
ma'am.
did wrong.
Okay, ma'am.
I will try it in a different way. To check out whether there is an improvement. And now I can see some improvement, I think so. But for this case, I have to design a different. இது சார் கிளாஸ் ஆயிப்போ உங்களுக்கு. சரி, இந்த பிஐடி கண்ட்ரோலர் இருங்க, ஸ்பீக்கர் ஆஃப் பண்ணிடுறேன். அவ்வளோதான் இருக்கு சார். இந்த பிஐடி கண்ட்ரோலர் டிசைன் எல் நீ வந்து ஓப்பன்ல கண்டுபிடிக்கணுமா க்ளோஸ் லுக் கண்டுபிடிக்கணுமா? ஓப்பன் லுக் நீ கொடுத்துருக்குற அந்த சிஸ்டம்க்கு ஒன்றும் வரலையே, ரொம்ப ஆசிலேட்டரியெல்லாம் வருது எல்என்டி கண்டுபிடிச்சா. ஆமா, அதுல கண்டுபிடிச்சு நான் போட்ட 0.632 வருது. ஆனா அதை இன்க்ளூட் பண்ணா ரொம்ப ஆசிலேட்டரியா வருது. ஆமா 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 ஆமா. ம். ஆமா, எல் 0.6 கிட்ட வருது. ஓகேயா? அப்ப டி வந்து 2 கிட்ட வருது. கரெக்ட் தானே? ஆமா, அது போட்டேன்னா வரலையே. நான் ஒரு கால்குலேஷன் தப்பு பண்ணிட்டேனா? இருங்க, நான் ப்ரோக்ராம்ல என்ன கொடுத்துருக்கேன்னு பாக்குறேன். 3.76 தப்பா? நான் தப்பு பண்ணிட்டேனா? டிஏ 1.26 வருதா? டிடி 0.315. ஆனா அது ரிசல்ட் பாருங்க, தப்பா வருது. ரொம்ப ரெஸ்பான்ஸ்ல வித் பிஐடி ஸ்டெப் ஆஃப் பிஐடி கொடுத்துருக்கீங்களா? அதுக்கு ஆன்சர் வந்து ரொம்ப ஆசிலேட்டரியா வருது. செட்டிலிங் டைம் ஒன்றும் இம்ப்ரூவ் ஆகலையே. இருங்க, நான் ஒரு பிக்சர் எடுத்து அனுப்புறேன் பாருங்க. நான் மாத்திட்டேன் ட்ரான்ஸ்ஃபர் ஃபங்க்ஷனு. இல்ல, அது வரலன்னால நான் வேற ட்ரான்ஸ்ஃபர் ஃபங்க்ஷன் போட்டேன். ஓப்பன் லூப் ஆனா பிஐடி யூஸ் பண்ணா ஓப்பன் லூப் பார்க்க மாட்டாங்க. க்ளோஸ் லூப் தானே நீங்க போட்டிருக்கீங்க ப்ரோக்ராம்ல. எல்என்டி நான் ஓப்பன்ல இருந்து தான் கண்டுபிடிச்சிருக்கேன். ஆனா அந்த பிஐடி இன்க்ளூட் பண்ணி க்ளோஸ் லூப் ரெஸ்பான்ஸ் கண்டுபிடிக்கிறீங்களா ஸ்டெப்பு, அதுல தான் ரொம்ப ஆசிலேட்டரியா வருது. இருங்க, நான் கிராஃப் பார்க்குறேன். ஒரு தடவை காலை கட் பண்ணிட்டு அப்புறமா அனுப்பிச்சுட்டா. about you people? You got a different answer or same? You people are in meeting or not? You got any difference? I think we did confirm it. Trying a different system only. Again, I will ask you people to present. So be ready. This is the last time that I will ask you to present screen. So all should show the screen. Again, I'm asking you people are trying it out or simply staring at the screen. Okay, you people are able to hear me now?
Yes,
Yes, ma'am.
Okay, the thing that we did is correct only. Okay, I will tell you what we confused. Okay, see this graph you are seeing now that we have got with the inclusion of PID controller. Okay, so you are giving what input to all cases? What input are you giving?
Step input.
Step unit step input means what is amplitude? Unit
One.
step input, what is the amplitude?
One.
One. Okay, so this blue color line is representing what response? Red is representing what response? You can see to the legend and you can tell me. Blue is representing what step response?
Yes.
Without the inclusion of PID controller, without closed loop, open loop system response from which you have calculated LNT. Okay, so it is settling at what value? Is it 1 here at this point?
No, ma'am.
No.
No, ma'am.
Okay. Again, the closed loop also, if you observe, there also the response is it settling at 1?
No, ma'am.
No. Okay, that is why I got confused. Okay. So if you see after the inclusion of PID controller into the system, where does it settle now? You can see. On what am I circling?
One.
What is amplitude? One.
One.
Okay. So
One.
here, out of the 3 cases, where am I able to get the step correct reference?
After
Right.
addition of PID control.
Okay, so this is correct only. Okay, I was mistaken. Okay, so but the problem here is it is very oscillatory. Okay, if you want to reduce oscillation means you can by trial and error mix and match the values of KPTA, TD, and you can try to reduce. You overshoot. But here the settling time is not reaching at all, not available for all the other 2 cases. Here only the settling time is reaching. Okay, let me have the characteristics. Settling time. In the table only settling time is asked, so I am taking only settling time. So for all the 3 cases, you can check. Or even though it is showing settling time, it is not settling at 1. Okay, right. Settling time for PID is 34.5. There only you are able to get the amplitude, but for all the other 2 cases, it's not reached. Okay, reference is not reached, so not available. Your time. Understood?
Ma'am,
Hmm.
if we change the value of PD to 1.315, we are not getting an oscillatory output. We are getting a straight line, just only one.
Yes,
dp.
then that depends upon trial and error method only. You cannot simply change as you wish. Okay, slow and
Yes.
slow only you can change and check. So out of these 3, which is responsible for reducing the oscillation, which will make the system more stable?
Ma'am,
AP proportional
TD
or
to 1.315 I did. So
1.315 is very great. No, slow and slow only you can change. Simply you cannot jump to 1.3. It will not be good. So I have told you the salient features of the 3 controller PID, which is making more stable. Let me check out with the KP. Okay, 4 if I give, run again. Among the controllers, whichever constant is able to reduce the oscillations, that only you can change. Simply you cannot make ravish changes. Okay. Still the system is oscillating, so I cannot make any changes. So I will check out which I can change. Now I'll randomly pick one of you to show me the output. The presenting screen, whatever you have did there, you will show me. If you are not able to show me, then I will not be access punishment. So better all of you code in and obtain the output and keep it. Derivative type constant.
Ma'am, KP, if we reduce, we are getting less oscillations.
Which one
KP.
you are reducing now?
Yes,
KP,
ma'am.
I
Keep
did.
it near, somewhere near 1, ma'am.
Yes.
Wait. Okay. See, by reducing TD also, by varying I am getting C, I have reduced TD. TD is actually responsible for damping. Okay, so I have made some changes in TD. From 0.315, I made changes to 0.500. So you can clearly see the oscillatory behavior is overcome. Yes or no? Because you cannot simply go on increasing proportional gain, it will result in a problem. Okay, let me check. 600 if I give, then what will happen? Then also it's reducing. So 750 I will give. In 750 also it's reducing, isn't it? TD factor is actually responsible for damping. Okay, so you have to make changes in TD only, but the changes cannot be done in a drastic manner. You have to do it by small increment only. Okay, understood? You people understood or not?
Yes. Ma'am.
So here the settling time happens very early. Earlier it was 34.5. Now it is settling at 8.01. Okay. So you fix it up like this only. You will be designing PID controller Ziegler-Nichols tuning. Okay. So now time for you to present the screen. Whoever is ready, present screen and you leave. Otherwise, shall I pick? I will stop presenting. Do you have any doubts? Ask me now. Or else I will stop presenting and I will ask you to present. Okay, Soham is presenting.
Can you see my screen?
Ma'am, can you see my screen?
Yes, whoever is ready, you present.
Ma'am, like this, I'm taking near 1, ma'am.
Wait. Okay, where you are taking one? So you are reducing the value of proportional gain now.
KP, ma'am.
Okay, so the output.
Ma'am, is this fine or should I change the value again?
Your graph is not shown to me. Only the program I am able to see.
1 minute, ma'am. Ma'am, now?
Yeah. Now, okay. Okay. Now your overshoot is completely below 1. Then
Yes,
your rise
ma'am.
time will reduce now. So you have to pick the correct parameter to vary. Okay. Random variation will be like this. Initial rising up to 1 is not there, no?
Yes, ma'am. That is not going
That's the problem.
the values.
So you have to pick the TD and you have to reduce. Okay. Then, okay. What about the other two codes? Finished?
Yes, ma'am.
If you want, you can leave Akshat. The rest of the students also get ready to present your screen. Today is the last class, so I want everybody to present screen.
Ma'am, can
Or
you
else you
see
are
my
not
screen,
leaving
ma'am?
that lab. The
Oh,
Soham
ma'am.
screen I'm seeing. Okay.
Ma'am, see.
Show the graph.
I'm changing the value of TD to 0.90.
Now I am seeing Shivanshu Harsh's screen. Okay, only one at a time should present. The others should wait.
Ma'am, now is it visible, ma'am?
Yeah.
Okay, ma'am. Ma'am, see, ma'am. I have changed the value of TD to 0.900.
You changed what value?
TD.
Okay. What
TD
value
to
you get?
0.90.
0.900. Okay.
And ma'am, if
What
you
about the
change
other two codes?
other ones here, ma'am.
Okay, ma. I quit presenting. Let others present.
Okay, ma'am.
Hey, Shivanshu.
Yes, ma'am.
Who is presenting now? Shivanshu.
Yes, ma'am. Are you able
I am
to
not able to see your profile only. I am able to see your screen.
wait? Ma'am, now.
Now I am seeing.
Ma'am, first one.
Okay.
Second.
Hmm.
Third.
So the output for the third one then.
Yes, ma'am.
Okay, ma'am. What value did you change it? TD.
1.76. 3.76.
KP you changed.
Yes, ma'am.
Okay. Quit.
What, ma'am?
All those who presented can leave. Shivanshu, Akshat, Soham can leave. The rest till you present, I will also be here. You also will be here only.
Now?
Yes. Who wants to present?
Purpose, ma'am.
Okay, present. Shalab is presenting. One at a time present. Wait till the others finish presenting. It will take only 1 second. Shalab screen now. Okay, Shalab. You finished all the other two codes also.
Yes, ma'am.
Okay, you changed what value? KP only you changed or TD?
KP is 4.86 and TD is 0.88.
You both you changed,
Yes,
Okay.
ma'am. Both I changed, then I got
Okay,
this graph.
Okay. So you quit and you can leave.
Okay.
Radhaj present. Radhaj.
Ma'am, can you see my screen, ma'am?
Yes, quit.
This was the This was the first code, ma'am.
Okay.
Second
What
code.
about the last program?
Third
You got,
last code. Yes, ma'am.
you did not make any change in the value?
Values I haven't made, ma'am. Should I make any changes, ma'am?
You reduce the oscillation. Okay.
Okay.
Okay, quit presenting. Will you? The
Yeah,
rest
yeah.
in class too.
Ma'am, can I leave now?
Yes, yes, I can leave.
Yes, ma'am. Thank you, ma'am.
Okay, others wait for 1 minute. Okay. Who is showing the screen? Viveka. Okay. You can leave Vivek. Okay, Vivek. Okay, quit. The remaining people also, quick. For those who are presenting, attendance will be given. Not for anybody. I am marking the names here.
Ma'am, should I leave?
Yes, Vivek can leave.
Okay, thank you.
Deepa Lakshmi. Yeah.
Ma'am, screen தெரியுதா ma'am?
Ma'am, can you see, ma'am?
Aniket screen தான் தெரியுது. Aniket.
Ma'am,
ஒரு நாள் மூணு பேர் பண்றாங்க ma'am. One all stop.
Man, Aniket. We used what values?
Yes, ma'am, Aniket. 2.7.
யாராவது வெயிட் பண்ணணும்.
KP values.
வெயிட் பண்ணுங்க. Okay, Aniket, quit presenting, man. Yeah, okay. The other two codes also if you
ma'am, you can
finished,
see.
no.
Yes, ma'am.
You leave, no. Deepa.
Can I leave, ma'am? Yes.
Oh, no. Aniket can leave.
Ma'am, can you see, ma'am?
Aniket can leave.
தெரியுதா ma'am?
Deepa, are you presenting or not?
present பண்றேன் ma'am.
Ma'am, can I present my screen?
Wait, Deepa is presenting. Let her finish. தெரியுது
Yes,
சீக்கிரம்
ma'am.
பிரசன்ட் பண்ணுங்க.
அந்த ஒரு தெரியுதா ma'am?
கிராஃப் எங்க?
ma'am screen
தெரியுது.
தெரியுதா
Okay.
ma'am? Okay ma'am, thank you ma'am.
குயிக் பண்ணுங்க. மத்த ரெண்டு கோட் முடிச்சதா?
பண்ணிட்டேன் ma'am. பண்ணிட்டேன் ma'am.
தெரியுது தீபா, தெரியுது.
Okay ma'am, thank you ma'am.
சரி. Quit. Mohit.
Ma'am, you can see my.
Mohit or Pratyush, wait for some time till your friends finish presenting now. Yeah, Pratyush's screen I'm seeing.
Yes, ma'am.
Quickly.
Yes, ma'am.
మ్యామ్ నా లీవ్ అవుతుందా మ్యామ్?
Ma'am, are you able to see my screen?
Deepa can go.
Ma'am?
Pratish, you were presenting or not?
Yes, I'm presenting, ma'am. Can you able to see?
Yes, I was able to see, but that MATLAB coding and all, I am not able to see. Only this. Okay. The figure. Okay, ma'am.
Yes, ma'am.
The other. Yes. Other two codes you
Yes,
finished.
ma'am. Yes, ma'am. Ma'am, can I
Okay,
leave?
then quit, ma'am. Mohit will present now.
I think ma'am is not there.
Can you see, ma'am?
हाँ
Soham?
अरे हाँ भाई
भाई तू तेरे में तो सोहम दिखा रहा है
पागल है क्या?
तुमको।
मैम ने देखी ही नहीं उसका
भाई मैडम कहाँ है?
अगर दिखा दे तो जा सकते हैं ना?
हाँ निकलो तुम जल्दी तत्काल प्रभाव से।
ठीक है,
गई है कहीं,
ठीक है।
रुक जा तू। हाँ तू निकल।
चुप बंगाली।
मोहित बाकी का 2
हाँ,
कोड
मेरे
भेजा
पास
क्या
आ गया,
उसने?
भेज रहा हूँ, रुक जा।
अरे क्या इतना क्या गुस्सा
अबे
आ रहा
एक
है बे?
दिखा के निपटा दे।
हाँ वही करूंगा। श्रेष्ठ अभी ना जाके दिखाई निकाल गया वहां से।